recording on this computer. So first off, I sent out an email last week saying that the exam would be on Tuesday, and then I sent out an email saying that's wrong. It's going to be on Thursday because next Tuesday's Rosh Hashanah, and I didn't check my calendar. Rookie mistake. So anyway, next Thursday, I'm sure you won't have issues with studying, but that does mean I'm probably going to include functions on that in basically the form that you've been doing them. Sorry, no more advanced than the form you've been doing them for lab 4 and 5. Okay, lab 4/5, I should say. All right. So today's exercise is going to be found. Computing statistics with Kiva. Okay. So this one is going to be project 6, which is going to cover writing a few functions, but also doing some basically using a basic use case for kind of real. This is actually, we're getting into stuff that we could actually realistically do with Python with our knowledge at the moment. In fact, all you're really missing for you to really automate something that would normally take you a lot of time to do is the ability to read files, which is actually fairly straightforward in Python. In other languages, it's not so straightforward. Looking at Java, or at least older versions of Java, and C, where if you're reading a file, you're reading it character by character. That's a real pain to deal with. All right. So, but again, I will send out more but again, so the practice exam I sent out should still be valid. So we'll go with what I am saying, with what I'm doing for, sorry, we'll go with what the schedule says. For next Tuesdays, I'll decide whether I'm just going to be lecturing from home or if I'm just going to be giving you guys a pre-recorded lecture. I'll be deciding that. But probably won't be in class because again, it's Rosh Hashanah. So, and let's see. So, computing statistics with Kiva. So Kiva, if you aren't aware of Kiva is a nonprofit microloan service, meaning they gather a bunch of small lenders together to make still pretty small loans to people. Depending on the service that they're able to work with, they either charge interest or they don't with their clients. But the point being is that they're getting loans of like $500, and this gets to the fact that basically that the power of the dollar in the U.S. Is much, much different than the power of the dollar in other countries, right? Where the cost of living is much, much, much lower, and the amount of pay is much, much, much lower. So it's a very good nonprofit. It's been going on for years. At least, I mean, for years upon years and years. The minimum loan that somebody can pay is $25. Give is $25, and typically, and what happens is that basically you donate $25 to Kiva. You choose what the $25 goes to, and eventually that $25 gets repaid, and then you choose another project to lend that money out to. You can, so it's kind of just keeps, the money keeps going out and helping more people. So anyway, it's a pretty good nonprofit, but generally, if you're working in any kind of business that deals with a large number of clients or a large number of people or a large number of services, then you'll be keeping track of those and having a lot of bookkeeping. And then we can use computer programs to analyze that bookkeeping to tell us interesting things about that. Now, this again can be found by going to Runestone Academy, going to our fall 2022 Rosen, and then going all the way down the page. So start at the top, go all the way down to project 6, which is computing statistics with Kiva. Okay. Now so the data set that we're going to be working on is a small is a small slice of a real data set. So we're working on actual real data here, just a small segment of it so that it's reasonable to watch. So an example of this data is kind of this spreadsheet. Here they give us, I think they say, I forget, 40 rows, something like that. But the number of rows that the real data set has is 1.4 million rows, which would take up a lot of the page and wouldn't enable you to really eye check anything, right? So we want something big enough that basically the problems we're asking are non-trivial, but small enough that we can check it by eye. All right. So what is the data we're looking at? So again, this is a microloaning service. So what it's taking a look at is these different categories. Sorry, each row has this different data point. Each loan has a unique ID number identifying it, right? Because you can have, and we use numbers because programmers make assumptions about names, and assumptions about names are really bad to make. Okay, some assumptions about names is that people have names, people have a first name, people have a last name, people have names that don't change. People's names don't change based on who they're talking to. Very bad assumptions about names. Those are all wrong assumptions. So most websites, they don't bother going for your name, especially since the most obvious case, and the assumption you don't want to make, is that names are unique. Names are definitely not unique. When I was in middle school, I literally entered the middle school at the same year another Andrew Rosen had graduated from middle school. So a lot of questions about whether I was related, not to my knowledge, you know, but again, your name isn't unique. So, and neither is the person. So we want data ID. We want something that's a unique number guaranteed to that loan. Next, loan amounts. How much money is lent out? And how much was that loan? Does that person totally owe? Oh, you know, will that person owe? Where the country to where this was funded. So this was in Azerbaijan, El Salvador, Bolivia, all sorts of different countries. Status, whether or not it was funded, whether it got funding or did the fundraiser time expire, and then how long it took to raise. Now, it doesn't tell you the units, but what's a good guess as for what that unit is for time to raise? Sorry? Seconds, yeah, seconds, because that's a lot of hours. That would be a lot of, if it was hours, that'd be a lot of days. And if that was a lot of days, I think people would have died before they got the money. So, and then basically how many people how many people were needed to make that loan happen? So 38 people contributed different amounts, not always equal amounts, right? People can donate as little as $25, but they can donate more. Like over here, this was a single loan that was funded by one person of $100, right? Whereas this $1,200 loan needed 42 people. The $700 loan needed 28 people, right? This one in Uganda was funded by one person, 1525. So there are a lot, again, there's a lot of these loans, but this is the kind of data, and I'm sure there's more columns of interest for the data, like narrowing down the geographic area and that kind of stuff. But for publicly available stuff, this is fantastic. So to keep the code a bit easier and cleaner, they say what we're going to be doing is that they are automatically going to be including these 4 lines of code in the rest of our coding blocks. So this just simply sets up each of the columns for us, and specifically each of the columns and rows in a list format that we care about. So specifically, like, we care about the loan amount, the country name, the time to raise, and the total of lenders, right? Loan amount, country name, time to raise, and the number of lenders. We don't care about the ID because we're not trying to distinguish one from another. And we don't care about the status because they're all the same. So it'd be useless to save that, right? Now, what we've done is that we have taken this table over here, or taken these columns, and I've restored each value. So the first loan in the list had $1,250, and the second has $514, then $1450. The first thing in the list was, so that was $1,250 from Azerbaijan, $500 from El Salvador, $1450 from Bolivia, and we can see that that maps up. $1,250 from Azerbaijan, $500 to El Salvador, $1450 to Bolivia. All right. So again, what we can do, and again, this automatically gets loaded. So if I say loan, if I go ahead over here and print loan underscore amount, let's see, is that plural or singular? Singular. Run it. I mean, obviously I fail the auto grading because I'm just trying to make a point here, but it prints out the list, even though I didn't have the list, I didn't write down the list. Like it says, it's loading everything into this, it's doing this code silently in all the boxes for you, so that we don't have to keep copying and pasting or clutter everything up. All right. So the important thing to understand is that is how we use the index notation, right? Loan amount 0 corresponds to 1250, which is the first item in the list, or 0th. We'll go ahead and say 0th. Then index 1 would be 500, then index 2 would be 1450. So in other words, 0, if you ask for, so if I were to ask for country name 2, then starting from 0, this would be 0, 1, 2. So country name, so if I were to do country name 2, that would get me Bolivia. Makes sense to everybody? Because that would be again, the item at index 2 or row 2. So this is basically we took the table and kind of just laid it on its side, essentially, is the easy way to think about it. So what we're going to do is we're going to ask some basic questions that we're going to be able to check by hand, but we're going to be able to also use our computers to solve. So how much money was loaned? What was the average amount of money that has been loaned? What was the largest and smallest amount? What was the variance of the money loaned? Variance and standard deviation. If you don't remember the equation, don't worry. I have to look it up all the time too. In fact, they provide, I believe they provide that for later down over here. They provide that. Next, other questions they care about are like, what was the average number of days that we needed to fund a loan? So those are kind of different questions that you might think of trying to figure out when you get this data. Again, and another one and this one's nice because this one takes into account two different kind of fields. So we're going to take these questions and we restate them in forms that are much more conducive to us figuring out problems. So here we want to compute the total amount of money loaned and store it in the variable called loan total. So we want a variable called loan total. And we want to figure out how much, money was loaned to all the people in this subset of data. And, you know, run the code to compute that. So now this is again going to be kind of our accumulator pattern, right? Where we are going to be reading data and then adding it. The difference here is that we're just, instead of iterating over a range, we're iterating over a list of items that has already been defined for us. Those of you coming for another programming language might be tempted to go like for I in range and then the size of the loan amount and then basically go index by index. Try to avoid doing that. You're making more work for yourself than in than you need to in Python. Instead, you want to use the for loop and the fact that it can iterate over any sequence that you give it. So go ahead and give this one a try. This one's easier to overthink than anything else. I also don't, and I think you've got a lot of leeway in how you solve it. So I'll give this one a couple minutes. People need help, I will be there. Move this. All right, remember that loan amount is already plugged in. You don't need to like copy the data in. It's already exists. Oh, nice. What was that question? Yeah, you have to explicitly tell Python that it is a variable that's on the outside. So typically when you're working and that's also bad coding practice, what you want to do is you want to have a function do the stuff and then return. Shame that the batteries are draining on this. So, okay. We'll go ahead and do this. By the way, anybody know what mic this is just off by their site and the fact that it's cardioid? If you ever work with audio, this is an SM58. Worthwhile knowing because it is the most ubiquitous microphone out there. Possibly the only other thing that's as ubiquitous as that is the SM57. So worthwhile to know. if you ever want to work with audio. Yep, and it is sure. All right, so first off, we don't need to put in the load amount. We don't need to put in the load amount, load it in. We don't have to copy it down. Like I've mentioned a couple times, the loan amount is, we don't need to do that. It's already loaded in, okay? So what we want to do over here is we can write a for loop that goes for loan in. Now, you can do you can do whatever variable, but I like to always make my variables make sense. So for loan in loan amount, so for each loan, and the way to read these, especially when you're iterating over a collection, is for loan, so for each loan in loan amount, so for each thing in the collection. Then what we can do is we can say loan total is equal to the previous amount that we stored in the loan total plus the current loan that we are looking at. And we don't need to print anything out because we're just testing it against there to see, does it work? And it does. So, but let me go ahead and print stuff out. So I will go ahead and print basically adding loan to loan underscore total. And what we'll see is that loan amount starts out at 0. And we take a look at the first loan, which I've said multiple times is $12.50. And we add that to 0 and we get $12.50. Then we add 500 to that amount for the second amount. And we add $14.50 to that amount, and so on and so forth. It keeps adding them. Now, if we wanted to write a function to do this, there's a couple ways we can do that. We could just simply, put everything in a function. But we could do def. Since you were trying to do a function, I figured it's worth pointing out since there's other people as well. We could do def calc loan, indent this, and we'd want to do return. And what we'd want to do is something like this. Total is equal to 0. Rather than doing loan total, it would be, I don't want to confuse our variables over here. And honestly, the previous way I did it is a bit better for what we're trying to do. Turn total. And just simply do loan total is equal to calc loan. In other words, I just did a function that did everything I did previously, which really didn't need to happen. The return and what does this return do? If you haven't watched the videos on that yet, this takes the value that has been calculated over here and lets me use it outside the function. It replaces the function call essentially, right? Just like how if you do just like in math, if you have a function where we say f of x is equal to 2, and then f of x is equal to 2x, right? In math. If you if your math teacher then asks you basically to calculate this amount, which is f of 4 plus 5, then you'd replace the f of 4 with 2 times x, which would be 8. So you'd replace f of 4 with 8 and then add that to 5. The same kind of principle goes on over here, where if we have a function call, the return tells it what to be replaced with. So now that we have that, we can, one last way to do this. We could actually do this in one line based off the ways that if they let us, we can actually do this in one line. loan underscore total is equal to sum loan amount, assuming they don't prevent us from doing it because we're hard coding that. Oh, yeah, it says we may not use sum. Okay. They didn't want us to use that because they wanted us to do it manually. But whenever you're trying to add all the items in a list together, it's such a common operation that Python has a built-in function to do that. Okay. So now that we've calculated the total amount, okay, and let me go ahead and share the more, how to say, straightforward bit of that, which would have been this. Let me go ahead and share this block because that's the one that matters. Compute the average amount of money loaned and store it in the variable loan average. So how do you compute the average of some collection of items, right? If you wanted to compute the average temperature, right, over the past 30 days, you'd take all the temperatures from the past 30 days, add them together, and divide by the number of days we're adding together, which would be 30, right? If you want to know what the average, if we have an exam and we want to know what the average grade is on an exam, we take all the scores of the students, add it together, and divide by the number of students, right? The premise doesn't change here because we're doing this in code. So what would we want to do? We'd want to calculate the number of loans and divide by the number of, calculate the total amount of loans and divide by the number of loans that have been made. All right, so so at 12:35, I'll come back to that one. On a non-programming note, it's also worth mentioning that I have been getting basically one email every day on average from a student in either 2168 or 1051 saying, "Hi, professor, I caught COVID. I need to skip out. I need to be away from class, or I took a positive test." Positive transmission rates are really high right now for some reason, so keep that in mind. If you need to stay home because you're feeling sick, stay home. If you want to go back to wearing a mask, then go back to wearing a mask. So it's just something to be aware of. I am getting a lot of emails, and to everybody who I say, first focus on your health. If you're well enough to concentrate on the classwork, then attend via Zoom. All right. Now we're gonna slice this one multiple ways. There are multiple ways to do this one. First off, let me just see what the running says. It says, hey, yeah, I need a lone average variable for our answer. I need a lone total, just like we needed in the last one. And then says we cannot use sum, so use a accumulator pattern, just like we did last time. So to calculate the, there are two, we need two things. The first thing is the total number of loans that, the total value of all the loans combined, which we solved last time. And I could just copy paste, but I'll rewrite it because it's super quick to do. And then the other thing we need is how many loans was that? So let's do that. For loan in loan total, sorry, not loan total, loan amount. For loan in loan amount, which is the list that holds all the values for our loans. Loan underscore total is equal to the previous amount we had plus the amount it is, which we can just simply, again, do that instead. and says increment loan total, increment the value that's stored in here by change the value that's stored in loan total by this amount. And that gives us the loan total. As far as how many, so we need two things. We need the loan total, and then we need how many loans were made. And we can manually count that too. Num loans is equal to 0. We'll do an accumulator pattern for this one. And this one's actually a fairly simple one. We'll just combine it. We'll do it at the same time as we're doing the other one, which is every time we see a loan, for loan and loan amount, every time so we're going to go through this sequentially. Each time we touch a loan and look at it, we're going to increment the number of loans we made, the number of loans we've seen by 1. Okay. And then our loan average then can be computed as follows. All right, loan average is loan underscore total divided by num loans. So again, to compute an average, the total number of things, it's the combined value of all the things divided by the number of things there were. Now, another way we could have done this is that we could have taken advantage of the fact that we know how many, that we've got programmed in Python, how many loans there would have been. We could have just simply asked we could have asked using len, which is short for length, len of loan amount. Okay, and that tells us how many there are. Yes. Index and length, what's the difference? So the index is the location where a specific item is stored in a list, whereas the length is essentially the size of our collection, how many things are currently in it. One of the things I like about Python is that everything size can be determined by the len function. In Java, it's annoying where it's dot length, no parentheses for arrays, dot length with parentheses for strings, and dot size for everything else. So I really enjoyed this about Python, that I can figure it out. And again, this can be, if we could use the sum, we can condense this into one line again by saying the sum of loan amount divided by the length of loan amount to calculate the total. All right. So here we're going to learn about two functions built into Python. Store the minimum value for min loan and store the maximum amount in max loan. Okay. Then store the name of the country that received the largest loan in max country and the name of the country that restored the smallest loan in min country. So this one is possibly the trickiest one because we get a value and then we got to find out what index that value is attached to. So we've got two functions that are we've got three functions that are going to help us with this. Two of which are built into Python and one of which is built into the list, the list object itself. First off, the min and max function figure out what the minimum and maximum of something are respectively. So if I ask for what the minimum of this, the maximum of this list is, so I'm just doing this line. If I figure out what if I want to know what the maximum, the biggest thing in this list is, max will tell me. It was 21. That's the biggest thing. Similarly, if I ask for the minimum, it's going to tell me what the smallest thing is, which is 2. Finally, we've got one more function to do, which is, let's go ahead and see. So I've got this list. And I'm going to call it L. It's composed of 4, 22, 21, 4, 5, 2, 6, 8, and 9. So this is one of the more useful functions, especially with the context of this problem, which is the index function. And it's asking for the index of something. So for here, I'm going to ask what the index of 21 is. And it's going to tell me 2, because it's saying 21 is stored in index 2. 0, 1, index 2. If I ask for the index of 8, it will give me 7, which is 0, 1, 2, 3, 4, 5, 6, 7. Makes sense. If I ask for the index of, if I ask for the index of some ridiculously large number, I will actually get an error in Python. It will crash and say, hey, that's not in there. But and the other caveat that you want to know that's about index is that if I ask for the index of 2, it's going to give me 1. Note that there are 2 2s in this list. It will always give you the value of the first one it finds. There are other arguments you can pass in that you don't need that can change the values of it. So you need 3 things to solve this, which are min, max, and then index. All right. So I will give you until 250 to solve this one, and then I will come and give you the answer to this. So think about how to solve it. It's okay if you can't solve it. This one's a bit of a tricky one. Yes. Because you're looking for our loan amounts are floats, and you were giving it a name. The loan amounts are, so scroll down, run it again. Just run it again, run it again. Says 100, and then so here, this is fine because it's smart enough to know that zero. When you get a variable area down here, where you're counting where is 18. Yeah, that's also good. So yeah, because you're dealing with a float. So you're looking for yeah, this is actually so is not on line 6, so this not solution on 100 steps, you should be steps. You need 100 steps. If we're having an error, it's going to have to be that. So there, we're going to make an error on line 5. So line 5 works fine. You get the max value. And in that, even though When I do this one, because I'm having trouble manipulating your screen. All right, so for testing purposes, I'm going to I'm going to begin by quelching some errors. Min loan is equal to 0. Max loan, we'll replace these with values that actually matter in a bit. Max loan is equal to 0. And then min country is equal to and then max country is equal to whatever. And so we've got some values here now. Okay. So how do I find the smallest amount that has been loaned? Well, if we do a check by eye, we'll see that the smallest loan amount was the $100 loan made over here to the Philippines, right? And that tracks with our loan over here, which is if we do min loan amount, if we run that, we'll see that that tracks. Same if I do if I try to figure out what the maximum loan, the biggest loan that was done on our data set here, which was $1,800. All right. So now the question is, how do we take these amounts and put them to the country? All right. So our smallest loan was the $100 loan, and our biggest loan was the $1,800 loan made to the Philippines and Georgia, respectively. How do I know that? How do I know that the $100 loan went to the Philippines and the $1,800 loan went to the to Georgia? I'm asking this in a non-trick question way. Okay, like how? Yes. Well, not that it said funded, but I mean, how would you know that it's funded? That specific loan is funded. How do you know that the $100 for the Philippines has been funded? How do we know that this goes to this one and that this does not go to this? Yes. Same row. They're in the same row. They're in the same row. I get columns and rows mixed up all the time. In fact, it's very common. It's even worse because in programming, you're going to be dealing with not only row and column, but X and Y. And if you think about that for a second, X's go across like this, okay? And you think of rows going across like this, but if you want to go across a row, you have to increment the column to go across the row. Yeah, it starts getting a bit brain bendy. It's awful. All right. So in other words, we need to figure out what the index that this is at is. Because if we figure out what the index this is at is, we can go to the same index in country name and get our value here. Make sense? And the way we can do that is so we'll go ahead and create a separate variable. Index of min is equal to, and again, this is what I was talking about when I started the problem. And this is where it gets a bit trickier, right? Because you have to think about a couple steps. This one actually, it definitely takes more than 5 minutes if it's the first time you've ever done something like this. Okay. So a bit unfair of me to give us that restriction, but I want to get you started on the brainstorming process to understand, like, it's sometimes hard to tell what's easy and what's hard. So index of min is equal to, well, is equal to a loan amount. There we go. That was your issue. Loan amount dot index min loan. So we're asking loan. So we're asking loan amount. Hey, you know this number you gave me when I asked for the minimum? What index did you find that at? Does that make sense? Right, it's not necessarily obvious. Don't beat yourself up if you didn't get this the first time. This one is actually not obvious if it's the first time you're trying this kind of operation. And although this part is obvious, which is that if that's how you do min, then to get max, all we do is just change min and max, right? Min and max are basically the same problem. You just change the number and whether or not you're looking for greater than or less than if you're actually manually comparing, right? So this tells us what the index is of one. This tells us what the index is of the other. And let's go ahead and print those out. Just temporarily print those out to see what we get. Print index of min, index underscore of max. And we'll go ahead and run it. And we get 5 and 16. All right. And going to our column, 0, 1, 2, 3, 4, index 5, that tracks for the Philippines, and I'm sure it tracks for the $1,800 because I'm not going to bother counting, to row 16, but that gives us the index. And now that we've got the index, whoops, scrolled a bit too far. We can figure out what the minimum country is by going and using the list here, country name, and asking for the index of min. And we store that. We'll see that now we're passing. It says, hey, Philippines, we were looking for Philippines. We got Philippines. Right now for the max country, it wants to see Georgia, but it's not getting Georgia. So we just ask it, hey, where did you, what is the country name that's associated with the index of where we found the biggest item? Right, again, this is the index where we found the smallest item, the index found where we found the largest item. This one's, again, tricky, but what's good about this is that these functions are pulling a lot of the weight. Min and max are built into a depressingly small number of programming languages. In something like C, you would have to manually go through and compare all the values in one by one to see which one is the smallest and which one is the biggest. And then you'd have to manually go through and see, hey, in this list, what's the first value I found that had this amount in it, so Python's really great in this regard because it actually does a lot of work that's very easy to take for granted. So compute the average number of lenders per loan and store it in the variable average lenders. Now it sounds like really hard to do, but actually all it's asking is the average of this. The average of this column. That's all it's asking for. So go ahead. So, and we've already done that, but let's go ahead and do it again just to make sure it's stuck, right? So computing the average again, this time of the average, the average of this column, the num lenders total column. All right, so you're going to want to use this variable num lenders total, and then you have average lenders. That is that is the actual average. And as regards to using a map in the chat, we could have done that, but you're bringing a bazooka to a knife fight there. So that said, maps, hash tables, dictionaries are my preferred answer for everything. It's just we want to use we want to do the fundamentals before we bring out the heavy weaponry. All right. This one, again, what we do over to compute the average, if we wanted to just simply do it in one line, which I don't know if they'll let us this time, but we'll do it anyway. Sum of all the numbers divided by how many things there were. And again, they don't want us to use sum, so to compute the average number of lenders, we'll need total is equal to 0 for I in range, not range, but num lenders underscore total, which I think is a terribly named variable. Total plus equals I. So for everything in this list, add it to total. And then we can just simply do total divided by the number of things we had. Okay. The next two are next one is very straightforward. Compute the number of loans made to the Philippines and stored in the variable Philippines count. So there's a couple different ways to do this. This one is silly though, I think, because it wants you to do the, so first off, let's go ahead and copy this. Now, anytime you've got a long variable name or something that you want to make sure you're not misspelling, just copy and paste it. Equal to 0. So over here, it's saying you should use a list method to count. It's actually wanting us to use a method that's built into the lists. Specifically, what it wants is that it's asking us to compute the total number of loans made to the Philippines. Well, how do I figure that out? Well, the one that would the column that tells me whether something was a loan made to the Philippines or not is the country name column. So I'd go through this column and ask it, hey, is this thing the Philippines? If so, I'll increment the counter that I have. Now we could use an if statement to do this, but honestly, we haven't, we could do that, but I'm pretty sure we haven't hammered the if statements too hard. So for name in country underscore name, if name equals Philippines extra P, then Philippines count plus equals 1. Increment the number of times I've seen it by 1. Did I misspell it? Probably. Yep, totally misspelled it. But again, we haven't really hammered if statements yet, correct? We haven't really done too much in the way of if statements. Although, that said, for Thursday, you definitely want to have read up on if statements, okay? For Thursday, you definitely want to have read up on if statements in order to get the full amount out of that exercise as possible. So if the name is equal to Philippines, increment it, but it says we want to use a list method to count. And in fact, we can do this one in one line because Python is awesome. It does a lot of awesome things for us. Where I could ask country name, and we can kind of ask it a thing that's a lot like index. Country name dot count. Philippines. And one line. And that what that will do is that it does exactly what it says on the tin. It counts the number of times something occurs in a list. If I ask for Antarctica, right, it should come out as 0 because there is no Antarctica list there because there's barely a year-long presence, barely a year-long permanent population in Antarctica anyway. The winter shift in Antarctica, it's actually very fascinating. There's been a number of documentaries about it. It's worth watching at least one of them. All right. So for each unique country name, print a line, and now let's do this last one. And I'll do this one right now, and then I will go over and then I'm going to talk about the exercise we'll do on Thursday. So for each unique country name, print a line that shows the name of the country, and then the number of loans made to that country, like this: Guatemala, 1. So again, this is just doing the same thing here, but in a for loop. So for country in unique countries, right? So for each of these, we want to fit for each of these country names, each country is listed once. We want to print out how many times it got how many loans were made to it. So we can, and again, we can do that fairly concisely. Print country, which will print out the country name. And then what we can do is country underscore name, which is the names of all the countries we have for each loan, dot count that country. Give me the count of that country. So print out that thing and give me the count of that thing, how many times it occurs in this list. And it works out fairly well for that. So I'm going to go ahead and share this code. Let me go back and share the previous code as well. All right. So let me go ahead and, so that is all for these exercises, but give me the chance to please talk about Thursday's exercise. Thursday's exercise is one of my favorites. It's a former homework. And what I love about it, what I love about this one is it doesn't matter how experienced you are as a programmer. It's still a tricky problem, no matter what. It's equally tricky. It's equally tricky. That's what I love about it. Equally, no matter how advanced or beginner level you are, because leap years are a pain. Leap years are a real pain. And it's worth knowing that. So it's going to be called Blame Pope Gregory the 13th, I believe. Is that what I had at the 13th? Because we name our current civil calendar, the Gregorian calendar, after him. So obviously it's his fault that we have to deal with leap years, even though that's totally not true. So but that one, again, because it's going to be we've been focusing a lot on loops. Tomorrow is on Thursday, there's gonna be no loops whatsoever. None. Zero, zilch. It's all gonna be if statements. So just keep that in mind for watching the videos. I'll be sure to have things sent out. And I'll send out more information about the exam as we get closer to it. Keep note of the new time. Class is dismissed. The new date for the exam. But, oh, I can't hear you. Hold on.
Give a chance to make them.
Yeah, just give me a second. Yeah, give me a bit to get a chance. Stop sharing.